either for mains or NEET, please do subscribe to my channel, especially for chemistry. I will update the mains papers as well as model papers for NEET and all. Which of the following element does not lie in the same period? Osmium, iridium, palladium, platinum. So if we consider palladium, it will be in the 4D series, whereas osmium, iridium, platinum are in the 5D series. Question number 2. Which of the following can show phase meridian isomers? A3B3 type complexes show phase meridian isomers, and in the given options C shows. Next one. Among the following most stable carbene ion is cyclopentadienyl anion, which gets extra stability due to aromaticity, is having the most stability among the given options. Next one. Which of the following pair of ions are same colored? So in the NCERT textbook, we have a table of ions and colors. By looking at the question, it is advised that you need to learn the table of ions and colors. Here both Cr+2 and Cu+2 are blue in color. So option 2. Next one. Calculate the percentage by weight of S if 160 grams of organic compound produce 466 grams of BaSO4. They are asking for percentage composition. So BaSO4, if we consider 233 is the molecular weight, in which sulfur weighs 32 grams. For 466, how much means it's 64. 64 divided by 160 into 100 will give you the percentage of sulfur. We are getting 40% here. Let's move to the next one. Which of the following reacts with the Hinsberg reagent? Among the amines, primary and secondary amines readily react with the Hinsberg reagent, whereas tertiary amines do not react with the Hinsberg reagent. Distinguishing test. Next one, statement type question. Fructose can give Tollens test even though it does not have aldehyde group. Statement 2, when reacts with the base, fructose can undergo rearrangement to produce aldehyde group. Yes, it's correct. In presence of alkaline medium, fructose rearranges. In the rearrangement structure, fructose has aldehyde group, hence it gives Tollens test. Next one, if 2 grams of phenol is allowed to react with bromine, how much bromine will be required to produce 2,4,6 tribromophenol? From the equation, it is clear that 1 mole of phenol reacts with 3 moles of bromine. So 2 by 94 grams of phenol reacts with how many grams of bromine? Let's calculate. Here the X you will get as moles. X into 160 will give you 10.2 grams. Approximately it is 10 grams because the bromine molecular weight is 160. From colligative properties, the next one. Here the given complex has 0.1 molar concentration, 100% dissociation, delta TF they have given, KF also they have mentioned, and they are asking us to calculate the formula of the complex. For this type of questions, first we need to calculate the Van 't Hoff factor I. I is equal to 1 plus n minus 1 into alpha, where alpha is degree of dissociation, 100% means alpha is 1. And by substituting all the values, we are getting n value as 3, and you need to look for the option with 3 ions, CONH3 of 5 times Cl within bracket Cl2. If 10 power 21 molecules are removed from x milligrams of CO2, then 2.4 into 10 power minus 3 moles are left. Then calculate value of x. Interesting question from mole concept. So molecules we need to convert into moles by dividing with Avogadro number. Thereby you will get the number of CO2 moles that are removed. Total moles will be 2.4 into 10 power minus 3 plus 0.167 into 10 power minus 3, where we are getting 4.07 into 10 power minus 3. Then 1 mole CO2 is 44 grams, but in terms of milligrams, it is the final value is 179 milligrams. Next one, incorrect statement among the following. SO2 acts as oxidizing agent but not reducing agent. The first one itself is an incorrect statement because SO2 S oxidation state is +4, which is intermediate. Hence, it can act as both oxidizing and reducing agent, but they have mentioned that it can't act as reducing agent. So the first one is incorrect statement. Next one, the d electronic configuration of an octahedral complex CO2 having the magnetic moment 3.95 Bohr magneton, and they are asking for the configuration. CO plus 2 has 3d7 configuration. The ligand must be a weak ligand so that we will have 3 unpaired electrons with the configuration T2G5EZ2. Next one is a matching question from thermodynamics. When volume change is 0, delta W is equal to 0. When volume change is constant, it is isochoric process. When no heat is exchanged, it is delta Q is equal to 0. Work done by the gas is equal to heat given to the gas. It is a isothermal process. Next one, a series of electrode potentials they have given. This type of model is very important from electrochemistry chapter, where we find out delta G values in order to equate the final delta G. So here the first one, FeO4 minus 2 directly convert into Fe plus 2, 4 electrons are required. So the net delta G is minus 4F E0. That E0 we need to calculate. But they have given two potentials. From those two potentials we calculate delta G1 and delta G2, where the net reaction delta G is equal to delta G1 plus delta G2, so that you get the E0 value as 1.7 volts. You can check all the answers, delta G, delta G1 and delta G2. Next one, it's a direct question where they have given delta H, delta S and T, and they are asking us to calculate the delta G value. Here we need to convert the units, kilojoules to joules, and 25 degrees centigrade we need to convert that into Kelvin, so that you will get the delta G as 1570. Here I forgot to mention the units for delta G. It is joule per mole. Next one, the correct order of stability they are asking. The first structure is anti-aromatic, the second one is aromatic, third one is non-aromatic. So if we consider the stability order 2 greater than 3 greater than 1, because aromatic character, the stability of aromatic compound is greater than non-aromatic compound, which is greater than anti-aromatic compound. Let's move to the next one. Statement type question. During the lesson test, covalent compound is converted to ionic compound. Yes, no doubt. In the form of NaCN, Na2S, the elements convert into the ionic compound along with the carbon. Statement 2, Na4 FeCN6 gives Persian blue color and reaction with Fe2SO4 thrice. This one also correct. Because the blue color is due to the formation of Fe4 FeCN6. Let's move to the next one. Here they have given propanol and formaldehyde, excess of formaldehyde in presence of alkaline medium. They are asking about the final product. So here the propanol first with excess reagent undergo aldol condensation, form a product, but with HCHO it undergoes Cannizzaro reaction and readily produce the final product as CH3C CH2OH taken thrice. Next one, matching question based on named reactions, where we can easily find out the products from the reactions. Sandmeyer, Schwarz, Urge-Fittig, Finkelstein reaction. All these reactions are the very important named reactions. I think you know already. So here the Sandmeyer matches with cyanobenzene, Schwarz reaction matches with ethyl fluoride, and ethyl benzene, Wurtzbach, and Finkelstein ethyl iodide. Let's move to the next one. 3-nitrotoluene. On a series of reactions, finally we got a product A, and they're asking us to calculate the molecular mass of it. So 3-nitrotoluene on bromination, you will get the bromine at ortho position of CH3, and followed by SnHCl, NO2 converts into NH2. Diazotization followed by phosphoric acid, the NH2 gets eliminated out. So the product is 2-bromotoluene with the molecular weight 171 grams. Next one, the first year topic, octet rule limitations, where BF3 is an electron deficient compound, CCl4CO2 is complete octet, PCl5BrF5 expanded octet, and NO is odd electron species. Direct question. Next one, for a sample of hydrogen atom, the wavelength observed is 656 nanometers during a transition. The transition is. So in the given options, we need to look for the lambda value for which we are getting as 656. The first option itself, we are getting 656 nanometers, where N1 is equal to 2, N2 is equal to 3. That means the first line of the Balmer series. Thanks for watching. Please do subscribe, like, share and comment for more updates.